What's the matter if a lithium battery pack can neither be charged nor discharged? Next, I'll use this multimeter to quickly troubleshoot the possible issues for you. This is a 3-element 14 series 48-volt lithium battery pack. According to its reasonable voltage range for overcharge and overdischarge, it should be between 37.8 volts and 58.8 volts. So we can adjust the multimeter to the voltage range to measure the output voltage of its positive and negative terminals. If the output voltage is 0 volts, then there may be some wiring errors at the output end, or issues like missed soldering, insufficient soldering, cold soldering, or desoldering. If the measured voltage is also within a reasonable range, but there is still no output, what should we do? We need to further investigate.
For example, there might be issues on the BMS side. Normally, the total voltage before and after passing through the BMS of a lithium battery pack should be consistent.
Let's measure it first.
The total output voltage of the battery pack itself before the BMS is currently 55.9 volts. After passing through the BMS, it should also be 55.9 volts.
Let's see if they are the same.
So currently it indicates the BMS is fine.
What if the total voltage before and after passing through the board is inconsistent? We use 0.6 volts as the critical point. If the voltage difference before and after the board is within 0.6 volts, this situation might be due to apparent charging damage or triggered charging protection. But generally, in this case, the lithium battery protection board can still discharge normally. If the total voltage difference before and after passing through the board exceeds 0.6 volts, first, you may have triggered discharge protection. It could be bidirectional charge discharge protection, or the discharge MOSFET might be damaged, or the sampling harness sequence could be incorrect. In these cases, normal discharge is impossible. You can prioritize checking if the harness sequence is correct. We can measure the voltage at the harness port sequentially to see if it increases. Now we'll use the multimeter to measure the voltage data of each series one by one. We place the black probe on the first sampling harness position and place the red probe on the second sampling harness position. Currently, it's 3.492 volts. Okay, keep the black probe still. Move the black probe backward. The second series is 6.98 volts. Continue accumulating downward. The accumulated value is 10.47 volts. The third string reaches the fourth string at 13.97 volts. Continue accumulating sequentially like this. The accumulated value of each segment should be around 3.5 volts. This indicates it's normal. The harness sequence is correct. Next, we continue investigating whether the MOSFET in the protection board is damaged.
Check if there is an issue with the BMS. Our procedure involves removing the harness from the BMS first.
Similarly, our output terminals also need to be disconnected from the load. Now, we switch the multimeter to the diode range.
We measure whether the BMS is conducting.
Okay, in the diode range, let's check. We use the red and black probes to measure the output voltage of the protection board. If it displays 0L or OL, it proves the protection board is conducting. The protection board is fine. If it shows a voltage around 0.4 volts, it means the MOSFET is damaged. If all this is normal, what should we do?
We need to further check the resistance value of the BMS's output terminals. At this point, we need to plug the harness back into the BMS. Then set our multimeter to the ohm setting. Let's use the multimeter probes to measure the resistance values of BMS's P's and B.
We will find the displayed value will gradually approach 0 ohms.
This indicates that the BMS is currently in good condition.
The MOSFET is not damaged. If the MOSFET resistance is infinite or in a non-conducting state,
it means this BMS's MOSFET is damaged.
Or there might be other issues with the BMS.
The check is complete. We've basically identified most of the issues with the multimeter.
Finally, I have a question for you.
If the BMS is triggered, why is it still possible to measure the output voltage? Let's discuss in the comment section.